Hello students, my name is Shayan Mitra, faculty member of Department of Electronics and Communication Engineering, Greater Kolkata College of Engineering and Management. Today's topic is about electromagnetic wave, subject code EC501. Today's topic is about the different kind of coordinate system and its transformation. In the previous lecture, we are discussing the different kind of features of cylindrical coordinate system. We have already covered the Cartesian coordinate system in that lecture, and now we are going to continue the lecture about the cylindrical coordinate system. Now we have described how the cylindrical coordinate systems are work around, what are the space variables, what are the coordinates, how we define the coordinates. Now we are going to jump into the different kind of mathematical consideration of cylindrical coordinate system and its transformation from Cartesian coordinate system to cylindrical coordinate system and the vice versa. So let's start with the lecture. So as we are discussing the cylindrical coordinate system, what we have here, we have the value of a 345.8. 3 is describing the radial distance of the cylinder, which provides us a circular cylinder, and this is the azimuthal angle phi, which will provide us a vertical plane along the p-axis, which has been described using this coordinates of this p has been described using these coordinates. Now the value 8 is nothing but the value of z, which will provide us a horizontal plane, this. So using this coordinate system, using these coordinates, we will get a perfect cylinder. Now here is the value of x is equal to rho cos phi, the value of y is equal to rho sin phi, and z is equal to z. It is nothing but the transformation of circular cylindrical coordinate system into the Cartesian coordinate system. Here the value of z of Cartesian coordinate system and the value of cylindrical coordinate system is same in both the Cartesian coordinate system and cylindrical coordinate system. It is the z axis, the representation of this coordinate is same. That's why we have described it using z is equal to z. Now if we have to consider the x is equal to rho cos phi, now how this has been extract, we are going to describe that. Now rho has been described as the radial distance of the point P. Now suppose the point P is situating here. Now the radial distance is from the z axis up to the point P. If we take a straight line, we will get the radial distance rho. Now parallelly at this point, it's also a point in z. Now if we parallelly draw a similar straight line which is parallel to this straight line, we will get this. We will touch the cylinder, the circular surface of the cylinder here. Now this angle, this angle has been described as 545. Now this is also rho and this is also rho. Now this, if we decompose this vector, we will get two components of this vector rho. One is along the x-axis and one is along the y-axis. The value along the x-axis will be rho cos phi and along the y-axis will be rho sin phi, and that has been what we have described, that along the x-axis the value of rho will be rho cos phi and along the y-axis the value will be rho sin phi. That's why this mathematical assumption has been proven. So that's how we can transform from one coordinate system to another coordinate system. So let's go to the next slide. Okay, now in case of cylindrical coordinate system, that one thing we should know, that rho, phi and z, all these coordinates are orthogonal to each other. So if we take a dot product of two different coordinate system, we will get a value of 0. Now that has been described here, the dot product of rho and phi and z, z and rho will be 0. Now if we take a dot product of the similar coordinates of the same coordinate repeatedly, we will get the value of 1. Now if we take a cross product of rho and phi, we will get that. Now as we know that rho, phi and z are orthogonal to each other, so if we take a cross product of rho and phi, we will get the value of z. And similar to that, if we take a cross product of phi and z, we will get the value of rho. And similar also, if we get the value of if we get a cross product of z and rho, we will get the value of a phi. So let's go to the next slide. This is the cylindrical coordinate system that we have already described, and this is the 0 to phi, the value of rho. This is the value of 0 to 2 pi of pi, and this is the value of z from minus infinity to plus infinity that we have already described. And the similar way, a vector A in cylindrical coordinates can be written as a rho a suffix rho plus a phi a suffix phi small a suffix phi plus a suffix z small a suffix z. Now if you take a summation of these three vectors, which is along the rho axis, phi axis and z axis, we will get the total value of vector A, where these are the unit vectors, and the value of rho will be x square plus y square, because as we have already seen that if we take a parallel draw a parallel line along the y axis and x axis, we will get the x square. The value of rho will be x square plus y square. As according to the Pythagoras law, we will get to know that rho square is equal to x square plus y square, from which we can determine the value of rho, which is equal to root over x square plus y square. And the value of phi, from this picture we can easily derive that the value of phi will be is equal to tan inverse y by x, and the value of z will be similar for cylindrical coordinate system and Cartesian coordinate system. So let's go to the next slide. The relationship between the a suffix x, a suffix y and a suffix z, and a suffix rho, a suffix phi and a suffix z are a suffix x is equal to cos phi a suffix rho minus sin phi a suffix phi. The value of a suffix y is equal to sin phi a suffix rho minus cos phi a suffix phi, and the value of a suffix z is equal to a suffix z, because it is same. Or we can describe it also in this way, that a suffix rho is equal to cos phi a suffix x plus sin phi a suffix phi y, and the value of a suffix phi is equal to minus sin phi a suffix x plus cos phi a suffix y. A suffix z is equal to a suffix z, we have already known that. The relationship between a suffix x axis, this coordinate and this coordinate, this one is Cartesian coordinate system and this is rho phi z is cylindrical coordinate system. The relationship is ax cos phi plus ay sin phi is equal to a rho minus a suffix x sin phi plus a suffix y cos phi a phi and plus a suffix z is equal to az. Because this is the vector which has been along the rho axis. The value of this is a suffix rho is equal to this. We have put this value in this, and we put the value of a suffix phi here. Now if we take the summation of these three value, now this is along the rho axis, this is along the phi axis, and this is along the z axis. This is similar, that's why both are similar. Now if you have to go through a suffix phi, the value of a suffix phi has been determined as this. So this is the value along the phi axis, and this is the value of rho along the rho axis, and this has been described using a suffix y and a suffix x, and this is also the same case. Now using these three things, we will describe the value of vector A, which is along the cylindrical coordinate system. To describe the cylindrical coordinate system, we use the x and y along the rho, along the phi, along the z, and this is the value of a suffix. This is the value of the vector along the phi axis, and this is the value of the vector along the rho axis. Using, now we described it using this x and the vector component of a suffix we will take the vector component a suffix x and the vector component of a suffix y. Using this we determine the value of the vector component which is along the rho axis, and similar for this. Now we are going to describe that how we have established the relationship of ax is equal to cos phi a suffix rho and minus sin phi a suffix phi. Now if we consider this particular equation, now this is the value along the a suffix x. It means that we are going to find the value of different component of cylindrical coordinate system along the x axis of Cartesian coordinate system. It means we have three different coordinate value of cylindrical coordinate system. Now we are going to determine the value of different component of cylindrical coordinate system along the x-axis of Cartesian coordinate system. That's why it has been described as the unit vector of the Cartesian coordinate system along the x-axis. This has been described as the unit vector of rho axis of cylindrical coordinate system, and this is also the same. This is the phi vector, is a phi coordinate which is in the cylindrical coordinate system. So we will describe how this relationship has been established. Now if we take a close look on this, now we'll go back to the this equation, this cylindrical coordinate system, where we are going to describe how the relationship has been established. Now this is the value of rho. Now this is along the x-axis, so the value of rho, the component, this is, we have already described that a suffix x is equal to rho cos phi. Okay, now if we consider the vector a phi which is along this line. Now one thing we need to describe here, that this z axis is along this way. The vector phi or a suffix phi will be in the direction of this way, and the a suffix rho, the vector a suffix rho, direction of the a suffix rho vector will be in this way. Both three of them are orthogonal to each other. So now if we have to consider which vector in case of cylindrical coordinate system goes along the a suffix x axis, and that is not a suffix z, and we have already considered the a suffix rho vector. Now the one thing we need to consider is the a suffix phi. The value of a suffix phi, if we break the a suffix phi vector in two different component, one, the value the one value will be the value of one vector component of a suffix y will be cos phi, another will be sin phi. One is cos phi a suffix phi, another will be sin phi a suffix phi, and this cos phi a suffix phi is in the same in the same line of a suffix x. The space variable a suffix x and the space variable a suffix phi, the component cos phi a suffix phi is in the same space. The direction of a suffix x is in this way, but the vector cos phi a suffix phi will be in the opposite direction. The space will be the same, but the direction is opposite. That's why from that we have described the value cos phi a suffix rho, that is along the x-axis, and also the sin phi a suffix phi. What we have done is sin phi a suffix phi, that is along the that is the same space with x-axis but in a opposite direction. Now if we consider this equation, and this will be plus, okay, so one thing I'm going to rectify that in another way, that this is, there is a sign, this will be a sign gesture, this is a plus, there will be a plus here, there is no, this is minus is right, but here it will be plus. So along the a suffix y axis we will get a value of the sign vector sin phi a suffix rho, which is along the y axis, and we will get the cos phi a suffix phi vector, which is the component of a suffix phi, which is along the y axis. That's why if we add them we will get the value of a suffix y. Now this is same, and from this equations we will get the same equation. We can extract all this equation. How? Suppose a suffix x is related to with this. Now if we have to find a suffix rho, we just have to pick the correct relation. A suffix rho is related to a suffix x with cos phi. Now we'll put here cos phi a suffix x. Now a suffix rho is in relation with a suffix y using sin phi. Now we'll just put sin phi here. Now if we have to determine the value of a suffix phi, now a suffix phi is in relation with a suffix x using minus sin phi. So here it will be minus sin phi, and the similar in case of, but this is plus cos phi. So here will be, we have plus cos phi. So using this equation we can determine, or we can establish a relationship. We can establish a relationship between the Cartesian coordinate system and cylindrical coordinate system. And from this value we deduct this specific vector a. We have represented this vector a in cylindrical coordinate system using the xyz relationship, using the Cartesian coordinate system. So let's go to the next slide. So yes, we have already described this slide. We will describe the next slide. This is the same thing. If we have to find the value of a suffix rho, we will just add this, and we have to find the a suffix phi. This is the vector along the phi axis. We will use this equation the same way, and we will find the value of vector a along the x-axis, the value of vector a along the y-axis. We will add them. We will get this value, and this is along the z-axis. Now the best way of remembering this, all this concept that I have been describing right now, or that what we have described just few moments earlier, best form of remembering all this equation using is in this matrix form, that a suffix rho will be a suffix rho will be is equal, a suffix rho, a suffix phi, a suffix z will be equal to cos phi sin phi, cos phi sin phi 0, minus sin phi cos phi 0, 0, 0, 1, and a suffix x, a suffix y, and a suffix z. And this is the matrix form. We using this matrix form we can easily deduct these equations. All these equations can be deduced using this matrix format. So let's go to the next slide. Okay, so now I'm going to describe the differential volume in cylindrical coordinate system. How it will be described? The same way as we have already described earlier, using to determine the value of volume, surface area, and line small length of using the Cartesian coordinate system. The same thing, the differential volume in case of cylindrical coordinate system can also be described using the same process, and this will be dv, it will equal to rho d phi and dz. Now how it will be described? Because to determine the value of d v, which is the volume of this infinitesimal small cube which is situated in the cylindrical coordinate system, can be described using, first we will take the product of the length, width, and the height. The height will be dz, which is here. The value of d phi, which is this, and this is this line. It is nothing but which is on the surface of the circular cylinder. The value of a circular cylinder can only be described can only be determined using the row into d5 format, where the row is the length of the this infinitesimal small point from the basically rho is the radial distance. Now if we multiply the radial distance with the angle, if we multiply the radial distance with the angle that specific infinitesimal small space is creating with the center, we will get the length of that specific arc. So this is the length of the specific arc, that is rho d phi, rho d rho, and this is the d phi, this is the value of d phi, and this is the value of dz. Now if we multiply all three, we will get the infinitesimal small volume of that space, this specific cube, which is situated in the circular cylindrical coordinate system. Let's go to the next slide. And these are the dot products of unit vectors in cylindrical and rectangular coordinate system. A suffix y, a suffix rho cos phi, a suffix y dot sin a rho is equal to sin phi, and vice versa. Yes, these are the list. Yes, so this is the one. This is the last example. How to transform the vector v. The vector v has been described using this into cylindrical coordinate system. So how will we going to do that? We will start with b suffix. Now how are we going to find the b suffix a rho? The b suffix a rho can be described as y ax, a suffix x dot a rho minus x into ay dot a rho. And b phi can be described using this. Then we will get the value of b dot a rho using this. We will put the values of y cos phi minus x sin phi, which is equal to rho sin cos phi. Yes, simple. This is along the x-axis. Now we will multiply with each and every one using a rho, because the a suffix z is constant, so we are not going to interfere with the a suffix z. If we have to transform from Cartesian coordinate system to cylindrical coordinate system, we are not going to touch the a suffix z. The value along the z axis will not be touched. We will only consider the value along the x axis and the value along the y axis. So from that, what we have done, we just multiply the a rho with the vector, with this and with this, and the value along the b phi, because the value along the bz will be same as zaz. So now along the b phi we will multiply the unit vector a phi, and we will get these values. Now we will put all those values get together. Yax dot yax dot a rho. Now yax, this y cos. Now this is ax dot a rho. This ax dot a rho will be cos phi, and the ay, that what we have already described in the list, that ax dot a rho is equal to cos phi, and the ay dot a rho is sin phi. Now I put that values here. Now y is equal to, we already know rho sin phi, and x is equal to, we know rho cos phi. Using this we will get the value 0. Using the same process, we will get the value minus rho, and from that we can describe that minus rho a phi plus z az, because along the rho axis the value of b is 0. So this is the final value. So that's all. We will end this class here, and we will start the next lecture with spherical coordinate system. Thank you.